Okay, so we have the x-intercepts, -3, 2, 5, and the y-intercept at 30. And the instruction is to find the equation for this cubic function. Okay, I'll start with the factorized form of a cubic function. Okay, it's going to be a times x minus the first intercept, so I'll say x1, and then x minus the second intercept, which is x2, and then x minus the last intercept, which is x3. Okay, just running out of space, but managed to fit it in. Okay. Okay, so these are my x-intercepts, as I pointed out. If we say x minus -3, we can write it as x plus 3. Okay, x minus -3 can be written as x plus 3. And then we have x minus 2. So there we're just going to say x minus 2. And then it's x minus 5 in the last bracket. Okay. Now, my equation is still not yet complete. I still need to figure out what is a's value. Okay, now to find a's value, what I'm going to do is I'm going to sub in a point. And it could be any point on the graph other than the 3 points that I've just substituted. So any other point on the graph besides these 3. And that point is the y-intercept. And we can see there from the y-intercept that the coordinates is 0 and 30. Okay, so that's what I want to substitute in the equation now. 30 would go for the fx, which is our y, and 0 is substituted with our x values. Okay, so I substitute that with 0. This is 0 plus 3, then 0 minus 2, lastly 0 minus 5. Okay, I'm going to do it slowly so you can see everything that's happening. 0 plus 3 is just 3, 0 minus 2 is -2, and 0 minus 5 is -5. Okay, if we multiply these 3 things together, 3 times -2 is -6, times -5 is positive 30. So here we have positive 30a equal to 30. So if I divide both sides by 30, 30 divided by 30 is 1, which means a is equal to 1. Okay. Now I finally have all the components. I found my 3 x-intercepts. In fact, that was given. And then I calculated what a is by substituting a point. So now all that's left for me to do is substitute a's value in this function and then multiply everything out. Okay. So let me erase it and get started. Or should I just do it here? Maybe I can do it here. No, let me just erase everything. Right. So I said I'm going to substitute a with 1, because that's what we calculated it as. But now, if you multiply something by 1, it doesn't really change anything. So I didn't even have to write the 1 there, because it's invisible. Now I'm going to multiply, pardon me. Now I'm going to multiply the first 2 brackets. So x times x is x squared. And then x times minus 2x is minus 2x. And then 3 times x is 3x. So the minus 2x plus the 3x gives us a positive 1x. And then 3 times -2 is minus 6. Okay. So I kind of simplified the 3x and the minus 2x to give me the positive 1x. Now I'm going to multiply this trinomial by the x and by the -5. Let's first multiply it by the x. So we get x cubed plus x squared minus 6x. Each of these terms get an extra x. Okay, now I'm going to multiply it by the -5. Okay, so we're going to have minus 5x squared. I'm going to continue here. Minus 5x and positive 30. That's the -5 times -6. That's your positive 30. You can now add your like terms. So the x squared minus the 5x squared gives us negative 4x squared. Okay, and then the minus 6x minus the 5x gives us minus 11x, and then the 30 is all on its own, so we just write that as is. Just give me a second, I'm going to go blow my nose, and then we'll continue with the second example. But you can copy this down in the meantime. Okay, so first copy down the new function, the second example, and then we're going to do it together. Just see if there's anyone that's trying to join the meeting. No, okay. So we have another cubic function, but notice with this one, we don't have 3 x-intercepts. We only have these 2 intercepts. Okay, that's because this is a repeated x-intercept. So the graph goes up, down, and then instead of going past the x axis and creating 2 intercepts, because it goes down and it turns and goes up again. So instead of creating 2, it just touches the x-axis like a tangent would. Okay, so the x-axis is now a tangent to the graph and therefore just touches, which means there's only 1 intercept. Okay, but like I said, this is a repeated x-intercept. So this is going to count as 2 x-intercepts when we are finding the equation for our graph. And then we'll use the y-intercept here, which is 32. We'll use that to work out the a value again, like we did in the previous one. So we'll start off in much the same way, where we say f of x is equal to a multiplied by all the intercepts. So it's x minus x1 bracket x minus x2. But now notice there isn't a third intercept because this one is going to be repeated. So instead of saying x minus x3, I'm just going to square this one because we basically multiplied by the same thing. Okay, so I'm just going to square this x-intercept or this factor rather. Okay. Now to begin the substitution, let's say x minus x1. So the first x-intercept is -4. If you minus -4, that's the same thing as saying +4. Okay. And then we minus the 2. And instead of writing again x minus 2, we'll just square this bracket. Right. We can now, I guess, multiply everything out. But actually, before we do that, let's first solve a. Okay, we don't know what a is equal to. So let's solve a by substituting a point. So for this, we're going to sub a point. And in this case, it's again the y-intercept. So we'll substitute 0 and 32. So 32 is our y value and 0 is the x value. In both places where you see an x, you need to substitute the 0. In both places. Right. So let's go ahead and simplify this. 0 plus 4 is just 4. 0 minus 2 is just -2. And I guess if you square that, that's also going to be 4. So can we do that in the next step? Let's square this, so it's 4. And then 4 times 4 is 16. So this is 16a. And this is 32 on the left-hand side. If we divide both sides by 32, no, sorry, we're going to divide by 16 on both sides because we want to be left with a alone. So we divide by 16 on both sides, and a is equal to 2. Okay, nice. So we have the answer for a. We also know what our x-intercepts are. We can use this now, I guess, to complete the entire equation. I think I'm going to leave this for a bit. Let me write here rather. Okay, so f of x is equal to 2 bracket x plus 4. That's our first intercept. And then x minus 2. That's the second intercept. But since it's repeated, we're going to square that one. Okay, so I'll start with this brackets that's being squared. And I'm going to multiply that out first. Actually, I need space now, so I'm going to erase this. The board is just looking way too busy. So we square the x minus 2. That becomes x squared minus 4x plus 4. Okay. Then I'm going to do the same thing like I did for the previous one. I'm first going to multiply everything with the x, and then I'm going to multiply everything with the 4. Okay. The 2 is still chilling on the outside. So if I multiply everything with the x, we get x cubed minus 4x squared plus 4x, sorry. Each of these terms get an extra x. Then I multiply them all by a 4, so that becomes 4x squared. This becomes negative 16x. And the last one is 4 times 4, which is positive 16. Okay. Now I'm first going to add up the like terms, and then I'm going to multiply everything by 2. So adding up the like terms first. X cubed is all on its own. Then we have minus 4x squared plus 4x squared. These two things cancel each other out. Minus 4x squared plus 4x squared. We then have positive 4x minus 16x. That gives me minus 12x. And then the last one doesn't have any friends, so he just goes all on his own. The 16 is the y-intercept. Actually, not yet. We first have to multiply everything by 2, and then that will be the y-intercept. So let's do that last step, and I'm actually going to just write the answer here on top because I don't have any space. So the final answer is going to be, I guess, 2x cubed, and then minus 24x, and then plus 16. Okay, that's our final answer. There you go. Any questions here, guys? Okay. So here we are given the function of f. which is x cubed plus ax squared plus bx plus c. Okay, there are three unknowns in this equation. It's a number in front of x squared, then the number in front of x, and the number in front of, or in fact, the constant, which is usually the y-intercept. In fact, which is the y-intercept in this case. Now, don't confuse this with a quadratic equation or quadratic function. Even though it looks similar, the fact that there's an x cubed out the front makes it a cubic function. Okay, so you have to treat this as a cubic function. The coefficient of x cubed is invisible 1. Okay, so we can assume that there's an invisible 1 in front of the x cubed. Okay, because they didn't put another variable there. If they put, let's say, d there, for example, then I'd have known that we have to still work out that as well. But now we can assume that we know what that value is, and the value is 1. Okay, so there's only these three unknowns that I have to work out. Now I'll start out with c, because c is the most obvious. C is equal to 12, because c is the y-intercept of the graph. Okay, so c is equal to 12. It's the y-intercept. Now what I need to do is work out the a and the b. That's the only two things that is still unknown at this point. Now from algebra, we know that whenever you're trying to work out two unknown variables, you need two equations. Okay, if you have one unknown, you can use one equation. For example, if I had x plus 5 is equal to 2, I could simply simplify this by, I guess, taking the 5 across and then saying x is equal to -3. Okay, I just need one equation if there is one variable. But if I had two variables, if I had, let's say, x plus y equal to 2, I can't solve x or y because there's only one equation. Okay, there's multiple values for x and y that will satisfy this equation. 1 plus 1 is equal to 2. So does that mean x is 1 and y is 1? But I could have also said 0 plus 2 is equal to 2. Does that mean x is 0 and y is 2? So we are unsure, and the only way you can solve this mystery is if I add another equation. If I said and maybe wrote another equation with x and y, then you would know exactly how to solve it, because you would do simultaneous equations. Right, you will use that one of those methods of simultaneous equations, either the substitution method or the elimination method. So I think you guys are more proficient in the substitution method, and so I'm going to create two equations, and then I'm going to do substitution. All right, so let's substitute this point. Right, I'm going to substitute x with 4, and I'll substitute y with -36, and then we'll find a first equation. Let me do that in blue. Okay, so y is going to be -36, and x is going to be 4. Can I just write out what I'm doing as well? So I'm going to say sub point 4 and -36. 4, sorry, that should be 4 cubed plus a times 4 squared plus b times 4. And then we're going to say plus c, which we said was 12. So let me put that in red, plus 12. Now let's just simplify this. 4 cubed is 64. 4 squared is 16, so this is 16a. 4 times b is just 4b. And 12 can't be simplified any further. Now, what we can do, though, is add our like terms. So here's a negative 36. On the other side is a 64 and a 12. We can add these things up, and then I guess take the 36 over and add it to that as well. Okay, so if you add up all the numbers, you actually get 112, because 36 plus 64 is 100, and then plus the 12 is 112. So we still have the 16a plus the 4b. Okay, I'll have 0 on this side. If I divide everything by 4, 112 divided by 4 is 28. 16 divided by 4 is 4a. And 4 divided by 4 is 1. So this is just 1b. Okay. Now, I said we're going to be using the substitution method. So that means I need to make b the subject of the formula. Okay, I'll keep b on this side, and I'll take everything else across. Meaning that b is equal to negative 4a minus 28. Okay, this is an equation for b. I'll label this as equation number 1. Now I want you to copy this down because I'm going to erase it when I do the next equation. So I'll give you like a couple of seconds to copy that down. Any questions here? Okay. Now, Josh, I'd like you to, sorry, why am I picking on you? Let me find someone else to also ask perhaps. Okay, cool. I'm gonna ask you to help me out with this next part of the equation. So to find a second equation, what I'm gonna do is use the turning point. Okay, so remember we said at the turning point, the gradient is 0. All right, the gradient here at the turning point is 0. It's a steep gradient over here, then it becomes 0, then it's negative gradient, then at this turning point it's again 0, and then it increases to positive after that as well. Okay, so you have positive, 0, negative, 0, positive again. Okay, now at this point where the gradient is 0, when we did derivatives in the beginning, we defined derivatives as gradients. Okay, and so what we can see here is that the derivative of f, where x is equal to 4, so this point where x is equal to 4, the gradient is 0. Okay, so this is the important statement. The derivative where x is 4 is equal to 0. This is going to help us find the second equation. Okay, so I'm going to do that by first taking the derivative of the function, then substituting 4 and equating that to 0. Okay, so sorry. Cole, could you help me find the derivative of this function, please?
I think it's 3x plus 2ax plus b.
That's correct, because the 12 falls away. I think you're missing something here.
Oh, 3x squared.
3x squared, yes. Okay,
And,
so 3, we bring it to the front, then we decrease that by 1, so it's 2. The 2 also is brought to the front. Oh, yes, 2ax. Thank you so much. I forgot that. 2ax plus b. Yes, because the exponent of this 2 is then reduced to a 1, and the 2 comes in front. And then this is just a number with an x, so the x falls away, and the constant also just becomes 0. Okay, now we said we're going to make this derivative equal to 0, And we are also going to substitute x with 4. So let's do that part. So this is not just a step that I want you to remember, but something I want you to understand. The gradient is 0 at the turning point. That is why we are making the derivative where x is 4 equal to 0. Okay, so the first thing I did is I took the derivative. Second thing, I made it equal to 0. And lastly, I substituted 4 with x. Okay, in fact, this step goes together. Equating it to 0 and substituting x with 4. Right, so let's continue. So 4 squared is 16. You multiply that by 3, which gives us 48. Then 2 times 4 is 8. So this is 8a. And then b is all on its own. Now, to make b the subject of the formula, we take the 48 across and we take the 8a also across. So I think I asked the question at this point, what was the previous equation that we got for b? Because this is the second equation. What was the first equation?
So the first one was b is equal to minus 4a minus 28.
B is equal to minus 4a minus 28. Okay, I wanted to say that it looks very similar. It's not exactly the same, but it does look very similar. Let's make these two equations now equal to each other because both of them is answers for b, right? B is equal to this and b is equal to that. So I can just make this part of the equation without b. I'm going to make that equation or that part of the equation equal to this part of this equation. Okay, and then we'll solve a. And once we have a, we'll then substitute back to solve b. Okay. Now I'm going to say minus 4a minus 28 equal to minus 48 minus 8a. Take the 8a across, it becomes positive. So now you have to minus it with this 4a. And then we take the 28 across. You'll have to add that with the negative 48. And so this is equal to, let me do the math correctly. I think this is negative 20. And then if you divide by 4 on both sides, a is equal to negative 5. Okay, that was the answer I was hoping to end up with. A is equal to negative 5. Now, to find b, we can substitute this answer for a into either of these equations. Okay, so I'm just going to choose this one. So b is equal to negative 4a minus 28. And I'll substitute a with negative 5. Just get this out the way. Substitute a with negative 5. Okay, so negative 4 times negative 5 is 20. And if you, this is minus, sorry. And if you minus 28, then you get negative 8 as your answer for b. Okay, so b is equal to negative 8. Now, since we have all the variables, a, b, and we even found c, c was 12, let's now write out the full equation for this function. Okay. So f of x is equal to x cubed, with the invisible 1 in front, minus 5x squared, because a is equal to minus 5, minus 8x, that's b's value, and then plus 12. Just get rid of this. Plus 12, that's the last part. There you go. Okay, unfortunately, I only managed to do one example, but this lesson is going to be recorded, or it is recorded, is being recorded, and will be uploaded for you guys to watch at a later stage then.